Okay, we're going to start Unit 11.7. Independent events. Two events are independent events if the occurrence of either of them has no effect on the probability of the other. For example, tossing a coin and then rolling a die are two separate events that cannot have no effect on what happens in the other one. Okay. If A and B are independent events, then the probability of A and B happening is the probability of A times the probability of B. That is this formula right there. We're looking at this example. The picture in the margin shows the family had 9 girls in a row. Find the probability of this occurrence. For simplicity, assume that the probability of female birth is 1/2. In actuality, about 49% of births are female. Okay, so if the probability of getting 9 girls in a row, okay, 9 girls is 1/2 times 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 1/2. 1, 2, 3, 4, 5, 6, 7, 8 times 1/2. Because having 1 girl does not affect what the probability is in the next pregnancy. Therefore, they are independent events, and then you would have the probability of 1/2 to the 9th power. I'm going to show you this on a calculator. Parenthesis. All right, 1 divide 2 parenthesis close to the 9th power, and it's going to give it to me as a decimal. Remember, math, enter, will give it to me as a fraction. You have a 1 in 512 chance of having 9 girls in a row. The second type of probability is called dependent events. That's when the first one has an effect on the second one. Okay, the probability of independent events, probability of A and B happening, is the probability of A happening times the probability of B happening given that A has occurred. Okay? So our example here is pretty easy to understand. Good news, you want a free trip to Madrid and you can take 2 people with you, all expenses paid. Bad news, 10 of your cousins have appeared out of nowhere and are begging to take you with them, or for you to take them. You write each cousin's name on a card and place the cards in a hat and select one name. Then you select a second name without replacing the first card. If 3 of your first 10 cousins, or if 3 of your 10 cousins speak Spanish, find the probability of selecting 2 Spanish-speaking cousins. Okay, this one is a little bit trickier than the other because if I was just talking about the probability of any 2 being, it would be the probability of any 2, 1 over 10 and 1 over 9, because there's 10 that you can choose on the first one and 9 that you can choose on the second one. Okay, but since we're talking about 2 things that are happening, the first one obviously and the second one are dependent upon each other. So the probability of the first being Spanish, ESP. Okay, well, how many Spanish speakers are there? There's 3. Okay, the probability of the first one being a Spanish speaker is 3 out of 10. Okay, once that person is chosen, it affects the probability of the second one. Okay, because there's no longer three that speak. Okay, so now we're talking about probability of the second speaking Spanish given the first did. Okay, so then that equals, well, now there's only two left that speak Spanish out of the 9 to choose from. Okay, so then it is 3/10 times 2/9. This is actually a good fraction refresher. 3 goes into 3 once, 3 goes into 9 3 times, 2 goes into 2 once, 2 goes into 10 5 times, 1 times 1 is 1, and 5 times 3 is 15. There's a 1 in 15 chance or probability that they'll both speak Spanish. Conditional probability, the probability of event B, assuming that event A has already happened, is called conditional probability of B given A. And we just talked about that. The probability is denoted by P of B, single line A. B given A happened. A letter is randomly selected from the letters of the English alphabet. Find the probability of selecting a vowel given that the outcome of the letter that precedes, that the outcome is a letter that precedes H. So that means that we know that the letter came before H. So the probability of getting a vowel before H. Well, let's write our words down. A, B, C, D, E, F. I know you love my singing. Okay, now here's H. We're talking about it came before that. So H is not involved. We've got 1, 2, 3, 4, 5, 6, 7. That is my whole. How many vowels are there? 1, 2 out of 7. Conditional probability, very simple. On to the next section.